Welcome to part 3 on the construction and use of a long compass. In the first part, we learned how to construct a long compass and use it to make arcs that have a radius that is too long to use a conventional compass. In the second part, we looked at why the long compass works and how to generate the correct offset angle for arcs that have a ratio of camber to half width that is greater than 10%. But there are cases where the long compass itself is not practical. For example, making the keel on a boat have a circular arc where the length of the beam or the keel is maybe 30 feet, and we want to have a rocker of maybe 1 inch over that distance. In those kind of beam lengths, the long compass gets unmanageably large. So in that case, a more practical solution is to use offsets. Another example might be making a form for a border on a road where the curve in the road is maybe 100 feet long, and it's got a radius of maybe 50 feet. In those kind of cases, it's much more practical to develop a table of offsets where we measure a certain distance along the baseline and then develop an offset and create a bunch of locations or points. Then we can connect these with a batten. We'll use this diagram to develop our formula. Remember from the last video that we could calculate out the radius of our arc based on our inputs of the half width and the camber with the formula W squared plus C squared over 2C. So we know that makes R one of our knowns. In the real world, our camber height is much smaller than our half width, and so it's more practical for us to measure for any given offset height what the offset along the beam's half length is. For example, if this was a total of a half inch, we might want to be making offsets at an even 1/16 inch along here, and it's much easier to put that point in if it's on our rulers measured to an even 1/16. For that reason, we'll make the offset our independent variable and the x value along the beam length our dependent variable that we will calculate. That beam distance I've got labeled as x sub 0 here, being the same length as this line here, and we can see that that length is equal to the sine, or r times the sine of omega. But what is omega? Well, we can also see that the cosine of omega would be this length divided by the radius. The radius is a known, and this length is a known because it's equal to our chosen offset height plus the cocamber. So the cosine of omega is equal to the offset height plus the cocamber divided by the radius. And our cocamber is equal to the radius minus the camber, so we can substitute that in. And so we get the cosine of omega is equal to r minus c plus our offset height, all divided by the radius. So omega then is be the arc cosine of that function. And finally, the x offset along the half beam is going to be equal to r times the sine of omega, and we can substitute that in as r times the sine of the arc cosine of this function. These kind of calculations are just perfect for a spreadsheet. Here's a spreadsheet I've developed, and the inputs are the half width. This example, it's 24 inches, and the camber of 1/2 inch. And these I've converted into 1/16, and then the spreadsheet calculates out the radius. Then I've inputted this 1/2 inch camber. I've spread it into 16ths so that when I actually lay out the camber, I can just read off an even 16th on the ruler. And this then is the offset from the center for that particular offset height. So at the center, the offset is 0, and it would be 1/2 inch or 8/16. And out at the very end of the beam, the offset is 24 inches, and the height is 0 there. So these are the points that you plot and then connect with a batten. And then if you wanted to change your dimensions, here's an example of a beam that's 8 feet with a 1/2 feet of, or 1/2 width of 48 inches. I kept the same camber, and the calculations work out then of this many inches offset from the center, and for each of those positions, this is the height where you'd put the point or nail. In both these cases, the input is the height of the offset, and the spreadsheet generates out the distance offset from the center using, for this column, this formula that we generated. Well, until next time, thanks for watching.